4-1, they're calling these fundamental particles. And we talked about 3 of them. Let's just refresh our memories here quickly. Subatomic particles. Pedro, name one for me. You know what I'm getting at? I really shifted gears here.
Yeah.
The little tiny particles that go to make up an atom.
Proton.
Protons, good. How do we abbreviate a proton? Just small letter p, lowercase p. What's the mass, Brittany? 1 AMU. Remember, that's relative scale, because a proton really weighs something times 10 to the minus 24th grams. Too small, too messy to deal with, so we use the relative scale, atomic mass units. What about a charge on a proton? Allison, do you remember? +1. And again, relative scale. Okay, I need another one here. Trent, can you tell me another? Neutron. How do we abbreviate a neutron? N. And what's the mass, Tron? No, mass. AMU. And charge? 0. Neutrons are neutral. Okay, Aaron, what's our third one here? Electrons. We usually abbreviate with the small e and also the sign. Aaron, what's the mass of an electron? Essentially 0 atomic mass units. Now, of course, we had this discussion before. Remember the cat with the fleas? Fleas do weigh something, but not enough to change the weight of the cat. Well, if we think of electrons as particles, they've got some mass. It's just, it's so small, like I think 1/2000 the mass of one of these. So we say it's essentially 0. And the charge, Alex, is -1. That was section 1. Okay, now, we're skipping forever and ever sections 2 through 4. This chapter has a lot of history of how they discovered electrons and all of that. It's not that it's not important, but we just don't have time for everything. So if you want some historical background, those are sections to go to. But the next one is atomic number. Atomic number. If I flash silicon, what's its atomic number? Anybody, just shout it. 14. We know the atomic number on the periodic table is written in the upper right-hand corner. And notice we got atomic number 1, atomic number 2. What did that atomic number tell us? If I took, here, let me write down silicon.
How many atoms?
Okay, I've got 14, and I round that to the nearest whole number, 28. Okay, protons, neutrons, electrons. What does the atomic number tell us? How many protons? We know immediately how many protons in the nucleus. And we had a discussion. You come down here to gold. It's got 79 protons in the nucleus. If you could make a platinum at a nuclear reactor site, accept a proton by firing high energy protons at the nucleus, you could turn platinum into gold. But that's a really bad idea, because platinum's worth more money than gold is worth. So, to be gold, it's got to have 79. If you're going to be platinum, you have 78.
Would you be able to take protons away from gold?
Possibly if you blast it, you know, when they talk about nuclear accelerators and all of that, that's not really my area of expertise, but almost anything is possible if you whack something hard enough, you can, you know, break it apart and change it into other things. Okay, so our atomic number tells us immediately how many protons, and if we're neutral, what else does it tell us? Number of electrons. Because if you're neutral, if each one of these is +1 and each one of these is -1, you've got to have an equal number. So that was section 4-5. 4-6, we just talked about neutrons, you know, the charge, the mass, so we've got 7. Okay, and 6, then let's move into 7 just real quick.
Wait.
You do the atomic mass.
Oh, yeah.
I did atomic number, and 4-6, I did neutrons very quickly, so we've been through that. And I'm just easing us into 4-7, but because it's, Andrew cleverly stalled for that last 30 seconds, so I won't get started with 4-7. Good work. Okay. Okay, your neutrons, it would be the atomic mass minus the atomic number, yeah. Okay, let's take a 10-minute break. When you come back, you're going to hear about Lab 8, okay? And then I'm going to say, do Lab 7, and then we'll head down and get started with Lab 8, and then I'll be passing back tests down